Alright guys, here we go. Page 5 in your antiderivative packet. And yes, I just realized that I said here I go again. But whatever. What we are looking at is the graph of f of x, which is shown right here. This is f of x. It's a semicircle and two line segments. G of x is the integral of f. This is huge. Whenever you see that one function is defined as the integral of another, what you want to make note of, G is the integral of f, okay? And this is always my little cheat sheet that I jot down, which means G prime is the same thing as f. Also, G double prime then becomes f prime. So what I'm doing is I'm taking the derivative of the left side and the right side. So here I bring everything up a derivative. The derivative of g is g prime, and if I take the derivative of an integral, it cancels. Now I take the derivative again. The derivative of g prime is g double prime. The derivative of f is f prime. So this is my little cheat sheet, which can help you answer all the questions. Okay? So now, if I look at part A, find g of 3. Well, if I want g of 3, then I plug it into my function. So g of 3 is the integral from 0 to 3, because where does x go? In as the upper limit. So now what I need to do is integrate f. That's my graph. How do I integrate from 0 to 3? Well, that means this is where I have to calculate the area above the x-axis and subtract the area below the x-axis. So what I'm looking at, this region here and that little triangle there. So what I do is I want to find the area of the semicircle, okay? So if I do that, the area of this, I'm sorry, it's a quarter circle now, because it was a semicircle, I want half of it. So that's going to be pi times r squared, the radius is 2, divided by 4. So that's going to be pi. So that's the area of that first region. The area of my triangle is 1/2 times base times height. Both of those are 1, so that's just 1/2. Therefore, already running out of room, g of 3 equals, g of 3 was the integral, so g of 3 is the area under from 0 to 3, pi minus 1/2. That is my answer for g of 3. Now, this should bring some memories back. Find all values of x on the interval, -2 to 5, that's my graph, at which g of x has a relative max, and justify your answer. Here we go. G has a max when g prime equals 0 or d and e, and has a sign change from plus to minus. So what you want to realize, if I want g prime to equal 0 or d and e, g prime is the same thing as f. So this means that I want f to equal 0 or d and e. That means I want the zeros or your x-intercepts. And if I'm talking about f, then my sign change means I'm going from above to below. So this is what I'm looking for. My justification and my answers are all about g, but I have to get my answers from f, okay? So if I look at my graph here, I need an x-intercept where I have a sign change from above to below. That's right here. That's at 2. Okay? So that's one answer. Now, part C. Again, blast from the past. Write the equation of the tangent line to g of x at 3. So what I want, y minus g of 3 equals g prime of 3 times x minus 3. So y minus, what is g of 3? Well, we conveniently found that answer in part A. So that's pi minus 1/2 equals. Now if I want g prime of 3, g prime of 3 is the same thing as f of 3. So when x is 3, f is -1. So this right here, that tells me that when x is 3, that's what I was asked for, g prime, which is the same thing as f, is -1. And there's the equation of my tangent line. Okay? So now, last question, find the x-coordinate of each point of inflection on g on the interval and justify. Here we go. Oh, I did it again. Sorry, guys. G of x has an inflection point when g double prime is 0 or d and e and has a sign change. So now, if I want g double prime to be 0 or d and e, g double prime is f prime. So that's what I'm thinking about. This means that when is f prime 0 or d and e? And that means that I'm looking for horizontal tangents or sharp turns, anything like that, okay? So if I set up my f prime number line, when does f prime equal 0 or d and e? Well, if I look at my number line, horizontal tangent, sharp turn. Looking at my graph, I've got a horizontal tangent at 0. This is tricky. When you switch from a semicircle to a line segment, you should consider that right there a sharp turn, okay? Because we don't have much information, so I want to look at all those changes in my graph. I'm looking at 2, and I want to look at 3, because 3 is clearly a sharp turn, okay? Now, my sign change has to be a change from increasing to decreasing or vice versa. My graph is increasing, so it's positive, decreasing, so it's negative. From 2 to 3, I'm still decreasing, negative, and after 3, I'm increasing. Therefore, my inflection points are when x equals 0 and 3, because at 0 I have a sign change, and at 3 I have a sign change. There you go. Hopefully all of that makes sense.